Left off last time we were talking about double angle formulas. So the double angle formulas are derived from our sum and difference formulas. I wouldn't say it's something that you definitely need to memorize because you can always get them. So if you remember when we talked about sine of 2x, we did sine of x plus x. So we did sine x cosine x plus cosine x sine of x. Do you guys remember all that? And we ended up getting 2 of the sine of x cosine of x's. Yeah, we already did this. So you guys have this filled in, right? And we went through the same process for cosine of 2x and tangent of 2x and so on. And so we ended up getting that cosine of 2x was cosine squared x minus sine squared x, right? And we wrote it in 2 different ways. So if we replace the cosine squared with 1 minus sine squared, we ended up getting 1 minus 2 sine squared x. And if we replace the sine squared with 1 minus cosine squared, we ended up getting 2 cosine squared x minus 1. Okay, do you guys remember all those different forms? All right, what was the tangent of 2x? So 2 tangent of x. Okay, and you can get all of those from the sum and difference formulas. Okay, so we kind of we were leaving off there. We did these first 2 examples, but we're going to start with these examples that I gave you. So it says, write each expression in terms of a single trig function, simplify if possible. So if we have 2 sine of 67.5 cosine of 67.5, we first recognize that that looks like 2 sine of x cosine of x, right? Do you guys, can you identify that? So that means that we're going to have sine of 2x. Okay, that's where we're headed towards. So all of this is going to equal sine of 2 times 67.5. Which is sine of, do you guys know double 67.5? So 60 times 60, or 60 plus 60 is 120, 7.5 plus 7.5, 115, or 15, jeez, I can't even talk today. 135, okay. Okay, if that's a unit circle value, I want you to go further. If it's not, then just stop. So some of your instructions on your homework just said things like, well, actually, I think that was on the sum and difference homework, right? Because I had Greta, you were texting me about that last night. Like it says, write as the sine of a single angle, right? This would be the sine of a single angle. But this is one that we know how to go further, right? But if it had been like 20 degrees, it'd be like sine of 20, and we would leave it like that. Okay, so sine of 135, that's, past 90 degrees by 45. So what's the sine of 135? Yeah, root 2 over 2, right? All right, so the next one, when you guys see 1 minus 2 cosine squared of 105, does that remind you of one of these double angle ones? Yeah, it's going to be the cosine one, right? So it's going to be cosine of 2 times 105. So it's going to be cosine of 210. Do we know that one? Mm-hmm. Oh, yeah. Here you go. So 210 is going to be 30 degrees past 180. Close. That would be it for the sine. Cosine. Yeah.
Oh, are you still allowed to do that? Because the other formula you gave us says that it has to be 1 minus 2 sine squared of x and 2 cosine of x.
Oh, did I do them in the wrong order? Dang. That's rough. Okay, so let's do 2 cosine squared of 105 minus 1 is what we're doing now, right? And let's be fancy. Let's put a negative 1 in front of it. Now I really confused you, didn't I? Okay, let me go back to the beginning. Let's start from scratch. All you have to do is put a negative in front of it, guys. So our formula, it says 2 cosine squared x minus 1 is equal to cosine of 2x. All right, this is almost it, right? So if I pull out a negative 1, I get negative 1 plus 2 cosine squared of 105, which is 2 cosine squared of 105 minus 1. Is that what we want? Yeah. So this ends up being negative 1 times what I was just saying, the cosine of 2 times 105.
What is the negative 1 inside the parentheses go away to become the 2 cosine x?
It did go away. Like this all became the cosine of 2x.
Oh.
And so I get negative 1 times cosine of 210, which, Kate, is what?
Negative root 3 over 2.
So I have negative 1 times negative root 3 over 2. So we get root 3 over 2. All right. The key is not to memorize everything. Like I do not have that memorized. That's why I made that mistake. So maybe I should memorize everything. But here's what I do. So if I see something that looks like I'm like, ooh, is that one of the cosine of 2x's? The only one I have memorized is this. So I do cosine squared x minus sine squared x. And then I replace. So I either replace this with 1 minus sine squared, or I replace the other one with 1 minus cosine squared. Does that make sense? And you can get those other two forms. All right, so the next one, sine squared of pi over 12 plus cosine squared of pi over 12. Is that a double angle or something we already know? It's 1. Done. Because it was sine squared plus cosine squared. And this next one, double angle, something we already know. What do we do? Yeah, this is double angle. This is going to be cosine of 2 multiplied by the pi over 12, which is cosine of pi over 6, which is, Kate, you on this one too? You got this?
Yeah.
It is root 3 over 2. All right. So then we have the ones where we have the little triangle sketches again. So we've done these before. We did these with the sum and difference. We did these before the last test, right? We've done these for a while. Are you starting to get these more? So when it says something, this time we said quadrant 3. How might I phrase that? I might say between pi and 3 pi over 2, right? I might say it like that as well, right? Do you guys all know that that means quadrant 3? Make sense? So we're going to draw it in quadrant 3, and we draw a little line. We connect to the axis. We put our little theta in. And we have opposite over hypotenuse. Okay, so the 2 is going to be opposite the theta, and the 3 is going to be on the hypotenuse. The hypotenuse is always positive. I never put a negative in for that. So what I'm going to do here is I'm going to think about the signs of my x and my y values. So what's the sign of the 2? It's going to be negative, right, because it's going downwards. Does that make sense? It's in the third quadrant. The x and y are both negative. But then I need to find this x value over here. So I find it by doing the Pythagorean theorem. So I'm going to say negative 2 squared plus x squared equals 3 squared. And sometimes they're not pretty. I've given you a lot of Pythagorean triples. I thought maybe you guys were, mature enough to handle this. We got this. So x is going to be plus or minus root 5. And in this case, is it the positive one or the negative one? It's negative because it's in the third quadrant, right? You guys get what I'm saying? So it's negative and then negative to get that point. So if I want sine of 2 theta, I don't have 2 theta. I just have theta, right? I have some angle that's between 180 and 270. Okay, but if I want sine of 2 theta, this angle is going to be between 360 and 540, right? I don't need to draw a new thing, though. I can use what I already know. So I know that sine of 2 theta is 2 sine of theta cosine of theta. So I find all of those things. So sine of theta is opposite over hypotenuse, negative 2 over 3. And cosine of theta is adjacent over hypotenuse. So negative root 5 over 3. So I end up with negative 4 root 5 over 9. Making sense? So then I go through the same thing with cosine of 2 theta. So I do cosine squared, that's one I remember, minus sine squared. Okay. So I have cosine of theta. We said that was the adjacent over hypotenuse, the negative root 5 over 3. So I'm going to square it. And sine is opposite over hypotenuse, right, squared. So I get negative root 5, which becomes, when I square it, 5, right, over 3 squared is 9, minus 4 over 9. So I get, I don't know why I wrote 5 over 9, 1 over 9. You almost got me.
In the sine 2 theta, when negative go away?
Both of them do, yeah. So this one became positive and this one became positive.
The sine, you have negative 4
That's because of this negative that was between them.
in this one above it. sine 2. And then you convert it
Oh,
back
yeah,
to
it is.
line.
Oh, yeah, I gotcha. Yeah, another error. Man, Monday morning. Gotta love it. Yeah, Claire got me. Did you guys see? I put them negative here. That should be a positive. Sorry, sophomores that are now watching this. They're probably screaming at the monitor. There should have been a plus. All right, so let's try some equations. Okay, so if we have sine of 2x minus cosine of x, we can't possibly solve things unless we have all double angles or we have all single angles. So we can either have all of them as x or all of them as 2x. We cannot solve it unless they're the same thing. Okay? So do you guys see how we have a double angle and a single angle? Okay, so we're going to change this sine of 2x into its equivalent form. We're going to say it's 2 sine of x cosine of x minus cosine of x equals 0. Okay? We have solved things like this 18,000 times. What do? Yeah, we pull out the GCF. We have 2 sine of x minus 1 equals 0. We set each piece equal to 0. And we solve. So we're going to find where sine of x is equal to positive 1/2 and where cosine of x is equal to 0. So let's start with cosine of x equals 0. Solutions? Yeah, we got pi over 2. We got 3 pi over 2. Sine of x is equal to 1/2. Oh, yeah. Not pi over 3, pi over 6, and 5 pi over 6. Those are our 4 answers. Easy enough? All right, so let's try the next one. Yep. So try the next one. Try to start simplifying things down, putting in your double angles, and so on. Okay, so if I start with the sine of 2x, cosine of 2x, I definitely have like my 2 sine of x, cosine of x. And we can reduce out by that cosine of x, right? So we're kind of getting there. We're like, okay, I got a 2 sine of x, but I have cosine of 2x still. That's not going to work for us. So let's change our cosine of x, or cosine of 2x. You can change it into anything that you want. If you want to make it, like the one that I said that I memorize, this, that's fine. And then you can take this sine of x over. And so you're like, oh, I got negative 3 sine of x's. But do you see how maybe we don't want everything to be like cosines and sines? Any ideas? Could there have been maybe a bit of a better form for us? Yeah, Greta? Yeah, maybe it would have been better if we had gone straight to the one where it's like 1 minus 2 sine squared x. But if you don't, that's fine. That's what I'm trying to tell you. You don't have to memorize every single formula that's in the identities. You can be like, oh, that's 1 minus sine squared x. And then you have another minus sine squared x minus 3 sine of x, right? And you try to get it into a form that we know. So we have negative 2 sine squared x minus 3 sine of x plus 1 equals 0. We're almost there. Yeah.
I don't think. How did you get the second minus sine squared of x? Because in the original formula, it's just minus sine squared.
It's from this part right here. So I think it was there, yeah.
I thought you switched it back.
I wouldn't put it past me. It's a nice morning here. All right, so what else? So we're gonna I would probably get rid of that negative. I've divided by a negative 1. Does this look like something that we've done before? I don't know if this factors though, does it? Did I mess up my factoring? I want that to be a plus 1. Forgot my squared. So this one doesn't factor, does it? Yeah, I messed it up. Darn. Curses. All right, but I was trying to get it to one where it was going to factor, and I messed it up. So let's go to number 4. This is a great day for you to observe. Man, I'm just really killing it today. All right, number 4, so prove the identities. So we can have equations that we're solving, and we can also have identities that we're proving. So remember, if we're trying to prove an identity, We're going to take one side and try to get it into the other side. So let's take our left-hand side. All right, so we're going to change our cosine of 2x into something. What do you guys want to do? Yeah, I would probably maybe do the cosine squared one. So 2 cosine squared x minus 1 all over 2. Our 1 minus 1's go away. And our 2 over 2's go away. So we end up with cosine squared. Is that what we wanted? Yep. All right, same idea here. Which side looks more complicated this time? The right-hand side. I'd start with the right-hand side. Yeah, wowzers. Do you see anything that can go away right away? Yeah, that denominator becomes 1. That's nice. So we definitely have a 1 on the denominator. What do we think for the top?
1 plus 2 sine theta cosine theta.
It's going to be cosine of 2 theta, but how do you get there? Yeah, you gotta like FOIL it out, right? So if we multiply this out, do you guys see how we have cosine squared theta? My outer and inner are negative sine theta cosine theta and positive sine theta cosine theta. Ugh, I'm running out of room. And then the last is minus sine squared theta. So these two terms are going to go away. And we're going to get cosine squared theta minus sine squared theta. Right? Over 1, which is cosine of 2 theta. So we got there. Do you see how it works? All right, so we're going to stop there for now, and then we'll do half angle next time. Am I going too fast?